Venkatesh. Hello, Venkatesh. Venkatesh. Hello, Venkatesh. Venkatesh.
Gerald sir. Sir, Gerald sir.
சார் சொல்லுங்க சார். ஹலோ. எஸ் சார்.
சார் சங்கர் சார்.
எஸ் சார்.
சார் இப்ப நேத்து ஃபீட்பேக் லிங்க்லாம் சப்மிட் பண்ணி எங்க ஸ்டாஃப் ஒருத்தர் வந்து சர்டிபிகேட் ரிசீவ் ஆகலன்னு சொல்லி சொல்றாங்க.
ஓகே சார்.
யார் அமுதன் சாருக்கு மெயில் அனுப்ப சொல்லட்டுமா?
அமுதன் சார் மெயில் இப்ப இந்த ஃபீட்பேக் நாளைக்கு
சார். சார் பிரிட்டோ சார்.
ஓகே ஓகே கண்டிப்பா அமுதன்.
ஒரு நிமிஷம் சார். உங்க ஃபேக்கல்டி பேர் என்னன்னு சொல்லுங்க சார். அந்த இப்போ உடனே செக் பண்ணி உங்களுக்கு சொல்லிடுறேன் என்னன்னு.
ஓகே சார். ஜெமிமா பிரிசிலா சார்.
ஒரு நிமிஷம். மெயில் ஐடி சொல்லுங்க சார்.
இந்த ஒரே நிமிஷம் சார், நான் அதை பார்த்து சொல்றேன் சார். சார் ஜெமி JEMI 1482@gmail.com சார்.
1482 இல்ல ஃபீட்பேக் லிங்கே சப்மிட் பண்ணல சார். இதுல வந்திருக்கும்ல சப்மிட் பண்ணிருந்தாங்கன்னா.
அத எனக்கு சப்மிட் பண்ணிட்டேன். ஒரு ரெஸ்பான்ஸ் ஷார்ட்லின்னு ஏதோ வருதுன்னு சொல்லி சொன்னாங்க. நான் ஸ்கிரீன்ஷாட் எனக்கு அனுப்ப சொல்லியிருக்கேன்.
இல்ல சார் இங்க சப்மிட் பண்ணிருந்தாங்கன்னா இங்க டேட்டா வந்திருக்கும். நேத்து உங்க பேர் என்னது?
என் நேம் சங்கர சுப்ரமணியன் சார். எனக்கு சர்டிபிகேட் ரிசீவ் ஆயிருச்சு.
அப்ப
நான் வந்து உங்களோட ஃபேவரட் தான் உங்க இல்ல.
சரி சார் சரி சார்.
ஏன்னா அவங்க நேத்து ஃபர்ஸ்ட் டைம் அட்டெண்ட் பண்ணாங்க. இந்த மாதிரி நான் சப்மிட் பண்ணேன் சார், எனக்கு வரலன்னு சொல்லி சொன்னாங்க. சரி நான் அதான் என்ன பண்றதுன்னு கேட்டுக்கோன்னு பார்த்தேன். சரி ஓகே சார், நான் ஃபைல்ட்ட கன்ஃபார்ம் பண்ணிக்கிறேன்.
நீங்க வந்து 12/2க்கு சப்மிட் பண்ணிருக்கீங்க. உங்களோடது 12/2க்கு வந்திருக்கு.
ஆமா.
அவங்க சப்மிட் பண்ணிருந்தாங்கன்னா கண்டிப்பா வந்திருக்கும். இன்னொரு சொல்லுங்க.
JEMI
இல்ல இல்ல
சார் இல்ல அவங்க சப்மிட் பண்ணல. அவங்க சப்மிட் பண்ணல. சாரி அவங்க சப்மிட் பண்ணல.
ஓகே थैंक यू சார்.
ஓகே சார் थैंक you சார். ஏன்னா அவங்க என்ன ரெக்வெஸ்ட் பண்ணாங்கன்னா கிட்டத்தட்ட ஒரு 1.5 மணி நேரத்துக்கு மேல அட்டெண்ட் பண்ணிருந்தோம் சார். நான் ஃபீட்பேக் லிங்க் வந்து சப்மிட் பண்ணிருக்கேன், எனக்கு சர்டிபிகேட் வரல அப்படிங்கிற மாதிரி சொன்னாங்க. நான் அப்பதான் அவங்க சொன்னேன், இல்ல அவங்க இந்த மாதிரி புதுசா அட்டெண்ட் பண்ணவங்களுக்கு இன்ஸ்ட்ரக்ஷன் கொடுத்தாங்க. எங்க அது வந்து 10 மினிட்ஸ் தான் இருக்கும், நீங்க அதை ஃபில் பண்ணா நீங்க சர்டிபிகேட் வாங்கிக்கலாம், இல்லன்னா நாங்க எதுவும் இது பண்ண முடியாதுன்னு சொல்லி சொன்னாங்க. பட் நான் கேட்டு சொல்றேன்னு சொல்லியிருந்தேன்.
சரி சார் சரி. இல்ல சார் இப்ப எல்லாரும் இப்ப யூடியூப்ல வேற போடுறோமா, யாருன்னு தெரியாதவங்கள நான் 1 மணி நேரம் அட்டெண்ட் பண்ணேன் லிங்க் கொடுங்கன்னு கேட்டா அது அதுக்கு தான் வந்து 10 மினிட்ஸ் கொடுக்குறோம். அதை வச்சுதான் பேஸ் பண்ணி தான் மானிட்டர் பண்றோம்.
சரி ஓகே சார், நான் ஸ்டாப் சொல்லிடுறேன்.
ஓகே थैंक यू.
ஓகே சார், ஓகே थैंक यू.
வெங்கடேஷ் சார் are you here சார்?
Hello, Venkatesh. Venkatesh, hello. Hello, Venkatesh, hello. Hello, Venkatesh. Venkatesh, Amudan, are you there?
Sir, I am here only, sir. Venkatesh is trying to present his screen, sir. He is trying now and he will present now, sir.
What he is going to present, sir?
He is not presenting, sir. He is testing, sir.
Okay, sir. Shall we start, sir? Hello, Mr. Amudan, shall we start now?
So, Brito, sir, my voice is audible, sir?
Yes, now it is audible, Venkatesh.
Okay, sir. Second, first Prabharan will handle over the section, sir. Next section I will take, sir.
Okay, so shall we start now?
Yes, sir. No problem, sir. Start, sir.
Okay. Good morning to everyone. On behalf of Ramco Institute of Technology, Department of Mechanical Engineering, IOT MECH Center, so we welcome you all for this webinar on Industry 4.0 3D printing. So yesterday we started with Industry 4.0, two major topics like artificial intelligence and also one more AR and VR. So today we are continuing the Industry 4.0 elements. So first session is first session is 3D printing and second session is Internet of Things, IOT. So first session will be handled by Mr. R. Prabhakaran. So he is working as an assistant professor, Department of Mechanical Engineering, Ramco Institute of Technology, Rajapalayam. So he completed his bachelor degree in St. Joseph College of Engineering, Chennai, Anna University in 2014. So he completed his master degree in Sri Ramanuja Engineering College, Anna University in the year of 2016. So for the past 3 years, he is working as an assistant professor in Ramco Institute of Technology. He is major domain area in additive manufacturing, welding technology, and CAD/CAM. So he is one of the in charge of MECH Center. So he is developing the additive manufacturing laboratory and also augmented reality, virtual reality laboratory. So he has published major journals and conferences in many. So now he is going to present the topic on 3D printing. He is going to present the basics of 3D printing and also advancement and current technology and also current trends in 3D printing in the industry and also academician. So he has attended Atal program in under 3D printing technology conducted by AICTE. So I think today the first two sessions will be very fruitful for your thrust area. So now I hand over the session to Mr. R. Prabhakaran.
So, good morning, everyone. Samudan sir, my voice is audible?
Yes, sir. It is audible, sir. You can speak.
Okay.
Yes, sir, it is audible, sir.
Yeah, thank you, sir. So, good morning to everyone. First of all, I would like to thank the Ramco Institute of Technology and the faculty coordinator who gave the great opportunity to share 3D printing knowledge to you all. Thank you, management. So, in this session, we are going to talk about 3D printing. So, we are in electronic world. So, 3D printing is the emerging technique. So, in mechanical engineering, it's a very wonderful thing. So, everybody have some idea about 3D printing. I'm going to just introduce what is the basics, what is that trends going on, what is the research area we want to focus. Like that, I'm going to give some idea. Here, I'm going to share my knowledge. Whatever I know, I will deliver. So, as per the NPTEL norms, IITians. So, 3D printing course is for 50 hours. We need to learn 50 hours. Need to learn the entire 3D printing. Here we have only 45 minutes. So, just I work hard and I have shortcut everything. Whatever in the 3D printing. I have shortcut and give a PPT presentation. Definitely it may be helpful for you all. So then and there, So you can comment. Definitely, I will watch all the comments here. So if you have doubt, definitely I will solve the time. You can chat every time, and also you can type always AOE in always. You are with me. I may understand you are with me. Definitely. So kindly conduct touch with me. So we will share so many things. So I'm going to present now.
சார் ஹலோ சார், அவர் கேமரா ஓபன் பண்ணாங்கன்னா சொல்லுங்க சார். அவர் ஃப்ரண்ட் கேமரா அதை எதுக்கு தேவையில்லாம ஓபன் பண்ணி வச்சிருக்காரு, அதான் குழப்புது. அவர் பிரசன்டேஷனை மட்டும் ஓபன் பண்ண சொல்லுங்க சார். ஹலோ
Hello, Amudan. Hello.
Yes, sir. I could hear you, sir.
Okay, you can start the presentation. Can you able to see the presentation, sir?
Yes, sir. I'm able to see, sir. Please. Yes, sir. Fine, sir. You can proceed, sir.
Yes, sir. Thank you, sir. Sorry for the interruption. So I'm audible, sir. My screen is visible.
Yes, sir. Everything okay?
Yes, sir. Yes, sir. Fine, sir. Go ahead, sir.
Hello? Sir, Vito, sir. Hello? Can you hear me, sir? Okay, a small instruction to the participants. Many of you might have joined for only today's session. The procedure what we follow is during the end of the session, we will be sending you a feedback link. After the presentation of Industry 4.0 3D printing and Internet of Things, we will be sending you a feedback link. Only if you have submitted your feedback link, you will be getting your certificate generated. Please wait for your certificate generation till today evening or up to tomorrow morning. You can wait. So if you submit your feedback link, only that will be considered as the attendance for the session. So please don't say that I attended the session but I have not filled the feedback form. So please do cooperate with us in this regard. Thank you.
Prabhakaran, sir. Sir, Amudan, sir. Hello.
Sir. Yes, sir.
Sir, your audio not available, sir.
Now I am audible, sir.
Yeah, yes, sir. Yes, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Thank you. Thank you. So first, we are going to discuss about subtractive manufacturing. Subtractive manufacturing, everybody know. This is for we have to cut the material. So subtractive, for example, we have to take for the milling lathe. So from the base material, we have to remove the material. This is for the subtractive manufacturing. In the every manufacturing process, have something disadvantage. So in subtractive manufacturing, the removal of material is very large. So to overcome that, so we need to go for something. So second one is, that is for the constant volume manufacturing process. So everybody know, just name onwards only differ. That is for the forming process. That is for the constant volume manufacturing process. So here also we need to consider more things. I mean, the allowances, stringage allowances, draft allowances. Allowances are most of we need to consider that thing. So we want to overcome the every process. We will go for the additive manufacturing. So here this is for the emerging technique. So research many of the research are also going on the very recent topic, additive manufacturing. So here, so additive manufacturing, we can overcome that removal of material, just we can adding the material. That is for the main advantages of the additive manufacturing. So other than this is for the industrial 4.0. So now we are in the additive manufacturing. Still the 5.6.7.0. Still many of the process may come. So everything will be the emerging technique. So every process we need to ask one thing. That is for the why. Why we are going for the additive manufacturing. So here I already told you the 3D printing lecture is only definitely minimum. I need 50 hours to cover some of the topics. So here the 45 minutes. So I have worked hard and I have shortcut everything. So whatever in the 3D printing I have covered in my 60 slides. Definitely it will be helpful. So you can touch with me. So here why we are going for the additive manufacturing. Everybody knows very well. So what are the disadvantages in the subtractive constant volume process, some other process. So we need to overcome. That's why we are going for the additive manufacturing. That is for the first thing. So here I would like to share something. I would like to share and shortcut something. So one of the major thing, and in world population, one statistics, 8% of world population are left-hander. This is for the one great example I took from one journal. Why we are going for additive manufacturing? And see, the remaining 92% are right-hander. So our commercial product, or every product in that we are producing the same way. So how we can modify? So the further 8%, how we can modify? So definitely we need some manufacturing process. So it may be the additive manufacturing process. That is also one of the major answer for the why. And also I want to talk about some technical point of view, that is called mass customization. If I am going to talk about mass customization, definitely it may take time. So I will give simple idea. Everybody aware of what is the difference between mass production, job shop production, batch production, and continuous production. So why I am going to say, if mass production means, everybody know that number of product is very high. So very high. Everybody know, if number of product is very high, definitely we need to go for conventional manufacturing. Additive manufacturing is not suitable for the mass production. Why? If you have to take for the cost curve, I mean break-even analysis. So additive manufacturing only suitable for the medium production or lesser production. If mass production, definitely we need to go for the conventional manufacturing. So here first one is that mass production. Second one is the batch production. Batch production means set of product. Only the number of varieties high, and every batches have some of the quantity. So in between that, we need mass customized product. Mass customized product means, so the mass customization is relevant to the how we can say simply, fulfill our requirement. We need mass production as well as it may be fulfill our requirement. So what we need to follow? The mass customization is called rapid prototyping. Mass customization product is called rapid prototyping. That's why we are going for the additive manufacturing. And also we can talk more thing. It may be the very compact, it may be the very accuracy, so eco-friendly, less cost. So and also one of the important thing, we can produce any part complex part. There is no we can go for any complexity parts. This is the some of the thing for why we are going for the additive manufacturing. And also I want to share one thing. One US hearing company producing part using 100% 3D printing. Why I'm here sharing? So now the trends come for 3D printing. So everybody using 3D printing very well. So we are the mechanical engineer. As a professor, we need to understand all the concept also, very important. That's why I'm sharing. So next, so we can simply define. So the WISI, WIP process. I mean, what you see is what you build. that is very important. I mean அந்த தமிழ்ல அந்த பிள்ளையார் பிடிக்கிறேன்னு சொல்லிட்டு எதையோ பிடிக்கிற கதையா வந்து இது இருந்துடக்கூடாது. I mean, so what you see is what you build. I mean, what you thinking, so it may be we want to produce, that is the final product. So what we need to follow, what are the considerations there, that is very important. So here the considerations are, so we want to adjust, compromise the temperature, we want to select the printer, we need to select the material, everything for the consideration. That is the thing here I want to share. So next thing, so name of the additive manufacturing. So here the first 10 slide, very basic thing. So I want to give some knowledge about basic, and only we can understand. So further slides definitely. So that's why I am sharing this one. So the name of additive manufacturing. So the name onwards a very confusing thing. Here this is just I have mentioned only 8. So there that more than 20s are there. But one thing, every name have a one specific meaning. That is very important. So I will tell one by one. This is very basic fundamental things. Then only we can understand the concept in the theory aspect. So first one is the additive. So additive, we can say it's several ways. One is the additive manufacturing, additive technology. Second one is the rabbit manufacturing technology, layer manufacturing, digital manufacturing, direct manufacturing, direct technology. So everything, so name for additive manufacturing. So the 6, 7, 8s are very favorable, and the research point of view, we are always using the journal paper. This is for the near net shape process. The near net shape process, so always define the dimensional accuracy, because if compared to the subtractive or constant volume process, the additive manufacturing is the near net shape process, because of, so we don't want to bother about any shrinkage. Here we can produce accurately the dimensional things. That's why this is for the near net shape process. So 3D means everybody know 3D means 3D printing. So what is the 2.5D? This is also one of the confusing thing. So nothing, everybody heard about CNC 2.5D machine like that. So additive manufacturing 3D printer also we can say simply 2.5D. So everybody guess that meaning answer, because of 2.5D means we have a X, Y, Z axis. So in 3D printer, so that is the more movement in the XY. So D means Z axis, that is the thickness level, that is very negligible thickness. So it may be called as the 2.5D machine also. So this is for the name of the additive manufacturing. Again, I remember every name have a, so every specific meaning. So I will tell one by one. So next, we can simply define 3D printing. So every journal, every paper, every textbook, so a lot of meanings and a lot of definitions are there. So we can simply say 3D printing. 3D printing means we can produce 3D object by means of 3D CAD model data without any tool material. We can define simply 3 things. We can get the 3D object by means of 3D CAD data file without any tool material. That's all about 3D printing and the definitions. This is the way we can easily remember the 3D printing techniques. So next one is the history. If you are to talk about the history, so many things are here. So in 1984, first started the stereolithographic techniques. So I will cover in the later on slides. So what is the stereolithographic and something. So second revolution, the fusion deposition modeling came. So and one is that, so functional prototype. So later on stages. So we are in 2020. So now we are going to touch for 4D printing also. 4D printing means everybody know. So many of them from computer design sector. So 4D means 3D plus 1D. So the 1D is called the time-based one. If compare the time-based in our mechanical engineering, only one thing we can remember, that is for the shape memory alloys. How to implement the shape memory alloys, how to it may be react with the temperature, pressure. So it may be comes under the category for the 4D printing, and also some research going on for the 5D printing. So we will talk on later. So next, so I'm going to talk about one basic thing. So here we are the very professors. So everybody know about 3D printing. So here so everybody is confusing about the basic terminology. So that's why I start with the terminology, and the later on slides I will cover some of the things. So here I'm going to talk about this flow test and those things very important. what I have discussed so many words. The additive manufacturing 3D printing means that is for the one of the technology. That is for the technology. So we can classify into two things. One is the rapid prototyping and the rapid manufacturing. Why I am sharing, it is not the same. It has a several meaning, and also we need to know more about these things. That's why I am sharing. Second one is the rapid prototyping and one is the rapid manufacturing. So everybody know about the prototype. This is the prototype. So prototype means that is for the model. This is not a final product. That is very important. Prototype is the model. So next one is the rapid manufacturing. The rapid manufacturing is the final product. So further it may be classified into so many things. The rapid prototyping, we can simply say that is the concept model. So we can say this is for the concept model. Second one is the functional prototype. This is for the rapid prototyping. So I will shortcut and tell how we remember these things. Rapid prototype means that is for the concept model. Concept model means we can simply say show and tell model. That is for the showcase, not is the final product. So for example, I will show the next slide. So next thing, this is for the functional prototype. First, we want to understand the two things. Concept model means that is for the prototype. That the next one is the functional prototype means we can identify the function before it manufacturing. That is the two things very important. These two things comes under the category for rapid prototyping. So I will tell with some picture. The picture is equal to 1,000 words. So here, this is for that. So one model. This is for the again, we want to understand these two things. One is the rapid prototyping. So next one is the functional prototyping. So here, this is for the jet engine. So we can easily identify this is not a final product. So this is for the only prototype. That's why it may be comes under the category for rapid prototyping. This is for the only model. So and also, so it may be rotating, actuating. So it may be actuating means we can identify the motion of that. So it may be comes under the category for functional prototype. That is very simple thing and a very important thing. So hereafter we don't want to merge rapid manufacturing and rapid prototyping. Rapid prototyping, the two things, concept model as well as the functional prototype. Concept model means that is for the rapid prototyping. This is the model, not a final product. And also functional prototype means from here we can identify how it may be act, how we can identify the motion. That is for the functional prototype. That is very important. So next we need to go for the rapid manufacturing. Rapid manufacturing means we can simply say this is for the final product. This is for the comes under the category of manufacturing. This is for our final product. Okay. So rapid manufacturing is also classified into two ways. So that is for the direct tooling as well as direct manufacturing. So we can simply say for that example, from this example, everybody can understand whether which one is the final product, which one is the die. So you can easily identify this is for the die. So this is not a final product, but this is the component just kind. This is for the final product. We want to understand this thing. This is the just kind is the final product. The die is called that is for the only die. So it used to, the die is used to make this product. So how I am correlate with our 3D printing? So in that case, rapid manufacturing, the two things, direct manufacturing, direct tooling. If direct manufacturing, if you can directly manufacture this just kind in 3D printer, that is called direct manufacturing. This is the approach is called technically positive approach. Whenever you get positive approach, so if I can say in the layman word, if you can manufacture in the directly in the just kind, that is called direct manufacturing. This is the negative approach. Negative approach means that is for the second classification, rapid manufacturing, direct tooling. If you can manufacture this kind, so if you can manufacture only die, that is called a direct tooling. That is very important thing. So because why we are considering, I'm going to going much deeper. So this just kind, this is comes under the category of mass production. Mass production, it is not suitable for additive manufacturing. Definitely we need to go for so traditional manufacturing, conventional machining. So conventional machining, the dies are very complicated. So dies are complicated. So better we can go for additive manufacturing. That is for the better result. So this is the way we can explain so many things. I hope you are understanding. So this is for the direct tooling. So again, two category. First, this is the direct tooling. We have manufacture die from the 3D printing. That is called direct tooling. Just within 2-3 seconds, I will remember those things. First thing is additive manufacturing. This is the technology. Not you don't merge anything. So the second one is the rapid prototyping. The prototyping means only the model. We can simply, technically, it may be defined as show and tell model, showcase model. This is for the two category concept, functional prototype. This is the final product. This is for the, we can identify the motion. Second one is the rapid manufacturing. Rapid manufacturing means that is for the manufacturing of final product. This is the two thing that is for the, so one is the direct tooling type. If we can manufacture directly in the layer in the every segment, in the single build, we can change the layer thickness in the we can obtain the various level. That is the adaptive slicing. That's why I have to remember here. So next one is here once again you can remember this is for that this is the genuine mechanism. It is not the final product. So this is for the rapid prototyping. So we can identify that motion. So it acts as the functional prototype also. So this is for the basic thing before going to enter the 3D printing. So definitely, so it will be helpful to understand the remaining things here. So next one is that here this is for the overall thing. So additive manufacturing 3D object from the 3D CAD without any tools. Rapid prototyping means just solid imaging concept also, FBT also. The two things comes under the category for rapid prototyping. If you go the deeply, FBT is the indirect manufacturing. So okay, I will discuss later. Rapid prototyping means that is for the show and tell model. So FBT means so. So we have to discuss checking and verifying. So FBT means that is for the show and tell model. So next one is the rapid manufacturing. So rapid manufacturing means that is for the final product. So final product means, so I mean that two classification. One is the so direct tooling and the direct manufacturing. If you can manufacture directly, that is the positive approach. If you can manufacture the laminate, you can manufacture only the die, it may be the negative approach. This is the way. So we can explain. And one is that I want to share here what is meant by secondary manufacturing process. Nowadays you can refer journal. So every journal they have mentioned secondary manufacturing process in the additive. So what is the secondary manufacturing process? That is very important thing. Nothing. So just to improve the property of existing additive manufacturing product is called secondary manufacturing process or indirect manufacturing process. Just for example, we have manufactured something in the SLS printer. So now I am going to do for the heat treatment for improving the hardness and the yield strength. So whatever we are doing for the secondary operation, that may be considered the category for the indirect manufacturing. I hope you have understand the basic things. So now we will move on some 3D printer type. So here just a layman word, 3D printer we can classify into three types. That is for the one is the Faber type. Second one is the office machines. Third one is the shop floor machines. So name onwards and fixture onwards we can easily identify what I am going to tell now. So Faber machine means that is for the we can use as a home appliance. So whatever we need in home we can produce in that simply in that Faber machine. So it may be comes under the rupees 30,000, 40,000. We can easily purchase the Faber machines. So second one is that office machine. So this is for that professional usage. So we can use for that education sectors as well as some of the small scale industry. So it may be very useful. Third one is the shop floor machines. Shop floor machine means you can identify from the image onwards. This is for the very mass production. That is for the medium production, and so that is for the industry, big industry they are used for the nowadays 3D printing. So now I am going to conclude here. So we want to confine. So what is here we can say correlate with what is the rapid prototype, what is the functional prototype, what is that rapid manufacturing, what is the direct tooling, everything we can say with the three machine. So for example, if you take the Faber machine, so we can produce the final product. We can produce the final product means, so next slide you can identify. If I am going to use for the Faber means, so main application level is the RPT. So again you want to remember RPT means rapid prototyping. So it may be again you remember this is for the show and tell model, this is for the showcase model. This is not a final product. The Faber machine is used for application only the RPT. So in additive manufacturing, the basic things, the wordings are very important for writing Java language. It's also very important things. So next one is the second office machine. Application level is the two things. One is the rapid prototyping. So you can remember FBT is the functional prototype. Yes, functional prototype, that is for the rapid prototype, and the functional prototype we can check the model as well as the function as well as master for secondary RPT. Again, you remember these words. This is for the master for secondary RPT means, so it may be act as for some ties, cores or mold. So it may be act as some master for the prototyping. So like that we can use for the office machine. So shop floor machine means definitely is the higher level. That is for the RMFG means, that is for the rapid manufacturing. Okay, rapid manufacturing means we can produce the final product. That is for the classification. You should understand the three things. And now I hope you are understanding this thing. You are with me, I hope. So next, now we have covered the two things only. What is the fundamental? So what are the basic terminology and what are the machine? What is the layman? We have to explain the application level. And the third one is that I'm going to talk about what are the stages for the 3D printing. This is also very important. So this is very basic thing. Just I have to remember once again. So if we want to produce that again, you remember additive manufacturing definition, we can produce the 3D part by means of 3D CAD model without any tooling. So first we need CAD model. That is the CAD model, very important. So computer aided design, everybody knows we can create, modify, analyze, optimize everything using the software. That is for the computer aided design. So again, you remember we have a lot of software. So basic level AutoCAD, SolidWorks, Inventor, Creo, so CATIA, Fusion 360, and next one is the NXCAD. So we have several Creo, several softwares are there. Every softwares are very useful for creating 3D model data. So after producing 3D model data, we have to insert in the slicing software. That is very important. So the intermediate gap, that is called what type of file it support for the slicing software. That is also very important. That definitely we need to understand what type file, what architecture there. That's I will explain the later. So here we can create 3D model in the 3D modeling software. After that, we need to save the file in .stl format. That is very important. So next slide, I will talk about the .stl file. So now you just remember .stl file. So this is the slicing software. The input is the .stl. That is the standard distillation language. So I will explain. So slicing software also we have a lot of software. This is for the some of the software in RIT MECH Center. We are using Cura. It is very user friendly. 3D slicer and repeater host and slick here. These all are the slicing software. So what conversion takes place? That is very important. Here only the modeling data. So slicing means everybody knows. So 3D printing first start with the point. Point means first one is the point. Second one is it may be converted into plane. That is for the 2D. After that it may be going to move the 3D. That is very important. Point, line, it built up with the 3D data. So this is for the stages for the slicing. So slicing means, so it may be created the number of segment in our 3D object. That is very important. And also one thing you should remember, in STL file everything stored in the triangular formation. So they will talk. So next, so the after slicing, just we have to take from here. We are using for that only memory card. So through that memory card, we have inserted in the machine. So machine we have so many MECH. So MECH Ultimaker, 3D Crudura. So so many machines also there. So here we are using MECH file. So from that machine, we have to get the final product. See here. So again, once again I remember. So model. So model will be converted into STL file. So STL file converted, just we have to feed to the sliding software .stl file. So it may be created for the somewhat slicing. So next we give to the machine. So it may be printed for our final product. This is so it depends upon machine. You should remember depends upon machine. Faber machine, or this is for that high level machine. It may be called as rapid manufacturing or rapid prototyping or rapid prototyping with the functional prototype. This is for the very basic technology. So next one is that and also we need to remember. So everywhere we have one disadvantage. Here also one of the disadvantage, that is called the supporting material. So what is the supporting material? From that image we can easily understand. So if my product is very complicated, this is for that some medium production, I want to manufacture this pipe-like product, but how I can produce in the 3D printing without supporting here due to gravity, it may be collapse. So with just I want to produce means definitely I want to go for the support. But the support is for, so it may be considered as for subtractive manufacturing. We want to remove support. So it is a rumber thing. So here I want to remove the support. So here consider first one is the 3D printer. So first we would like to select the 3D printer, and we have to select for that material. Material means it depends upon our application. So we are going for the polymer, we are going for that powder metallurgy, we are going for that some medical application, depends upon that PLA, so BEDG. So many we will talk about the later. So we can select the material. Finally, if it is very complicated, definitely we need to provide support. So from the support only we can achieve for the final product. So and also I want to share the one thing that is for the splitting. What is window splitting? Here in my PPT, I have just make up all those things in 3D printing. Split means nothing. Here, this is for the one of the part. If I am having on the faber machine, so if I can produce accurately in that ball means we can go for that splitting level. Splitting level means this is for the half of these things. Finally, we can achieve with the glue. So by means of glue, we can make it as ball. So this is also possible. Because of I hope you can understand the ball means we need many support because of it is for the lower pair, it is for the higher pair, it is for the point contact. So we need so many support. Without support we can produce. That's why we are going for the split for avoiding the supporting. So everything we need to ensure, that is very important thing. So next, so post processing. After fabricating the model, definitely we need to go for the post processing. And also you don't confuse, that is for the, so indirect manufacturing is different from the post processing. Post processing means just getting the dimensional accuracy, and we can apply for the color. This is comes under the post processing. Again, you remember that is for the indirect manufacturing means we have to improve the property. We are doing for the heat treatment, some of the property improvement things. That is for the indirect manufacturing. So this is for the simple post processing, just a support removal, and we have to apply for that paint grinding, for getting MRE sheets, apply for getting more surface finish. These are the some post processing techniques. So next one is I'm going to talk about the dot STL file. This is a very important thing. So without after, so again you should remember CAD model. So next one is the slicing software. Third one is the machine. So what is that intermediate? So CAD software to slicing software, that file is called .stl file. That is for the standard distillation language. Okay. So whenever we have to save this, so we want to select for .stl file. So in many of the book, many of the textbooks also, just we can identify the .stl file. One more also the .obj file. .obj file we can identify in the software itself. That's why we are mentioning the .stl. .stl, .obj, it support for tracing software. Okay. So and also I want to remember the thing. So in the .stl file, our product may be split up into missing into number of discretizations in triangular form. The surface of solid model with the triangle form. This is for the some of the technical begin in the .stl file. So next, so now we can understand so the overall concept. So here this is for the 8th thing. The 8th thing is whatever we have discussed. That is for the 8th thing. First I have produced here. This is for the our model. So second, so I have converted into .stl file. So here visible. So everything it may be missing into the triangular form. So final thing. So .stl file we have to feed to the slicing software. So after that, so it may be again you remember point line 3D thickness. So every 3D object converted into some 2D plane. So finally you will be get the object. So next from the sliding software we have to insert into the machine. So according to our instruction, the .stl architecture, so our machine will be up. This is for the stages of additive manufacturing process. So next one is that very basic thing. So here what is the advantage and the disadvantage? So advantage means first slide I already we have discussed why we are going for the additive manufacturing. So everything for our advantage. Because of you don't want to confuse with these things. So we know just cost effective, eco-friendly, we can make a very complex product. So, and also we don't want to worry about tooling, allowances, linkages. So everything comes under the category for the advantages. So next limitations. So everything, everywhere we have a limitation. Sometimes it may be costly material as well as the printer. And the very important thing for the 3D printing, still research going on how to improve the surface finish. This is for the major issues. So in the futuristic, in the research point of view, we need to ensure how to optimize the temperature in layer by layer. This is for additive manufacturing. The product is produced by layer by layer. How to optimize the temperature in layer by layer. That is for the one of the research trend. Second one is that how to get the surface finish. So and the third one is that how to avoid the supporting material. These all are the things we need to still research going on. So this is the second aspect we want to focus more thing. So surface finish, definitely we are going for the secondary process, post processing. Then only we can get for the final accuracy. So this is the way we need to understand. So next one is that fifth point is also that so failure rate is still quite high. So for overcome this one, industry 4.0, 3D printing is connected with IOT and artificial intelligence. So everything monitored in your own. So from that we can avoid some failure in the 3D printing. So everything we can overcome, but still we have some of the problem. That is for the research point of view. That is for the research gap. So next one is that these are the simple things. So everywhere we can use for the 3D printing. For example, plastic, metal, resins for the toys. So in home appliance also they are using for making bangles. So everything we can use for the 3D printing. And also in every industry adaptive, just adapted for 3D printing, the jewels, so healthcare. So we have in the biomedical, we can go for that PLA. PLA is one of that biodegradable material. It's useful for that scaffold. So and also the dental jewelry we can use for that some of the bandaget machines. So research area also we are focusing metal printing now. So everywhere we are using 3D printer. So in that just we need to update technology with the research gap. That is for the industry implementing. So next one is that. So next we are going for the 3D printing and the type. So there is this for the very important things. So next, so I'm going to talk about. So okay, still we have only 10 minutes. So still I have 50 more slides. So okay, definitely. So kindly contact with us. So through RIT MECH Center, we will update furthermore videos regarding 3D printer as well as the VR AR techniques. Kindly contact with us. So I will tell some of the things here, so and we will wind up. So here 3D printer. So first we want to understand. So metal based one. What is that? Powder based one. What is the liquid based one? And these are the very important things for classifying the 3D printing. So here I'm going to give some basic idea about all those things. Here first one is the FDM, that is for the fusion deposition machining. This is the very basic level machining. Again, you want to understand the basic terminology. So whether it is the rapid prototype or rapid manufacturing, or we can manufacture the direct tooling, everything you want to combine with these things. That is very important. FDM, that is for the fusion deposition modeling. So next one is, this is for the extrusion. So I will show definitely within a 5 minutes I will show what's going on our RIT MECH Center. So we had two things. One is that fusion deposition modeling, and also we are doing for some project work. So next consultants work we are doing for second, we have a digital light processing. I will show the two things within 5 minutes. So FDM is under the category of extrusion. The DLP is under the category of stereolithography. This is for that first. Nowadays stereolithography is costly, but we can avoid a little more supporting material and we can get more accuracy, but very costly. So again, you remember your history, that first history may be stereolithography. SLA means that is for the stereolithography. This is the metal extrusion. This is for the polymerization. Polymerization is this is for the liquid based one. Next one is the powder bed fusion. You want to compare these two things. So these two things. One is the selective laser sintering, as well as next one is the selective laser melting. So everybody can understand the 3D printing techniques, but the sintering means the mechanical people only can understand that sintering. So sintering means just it is not to go for the liquefaction state. That is for the solid itself, it may be melting and joining. This is for the solid state sintering. Here, if you go for the medical application, titanium, stainless steel, definitely we need a high power. Ultraviolet power is very needed, very high power needed. So that time we just focus for the selective laser melting. Okay. So next one is that binder jetting, and also that is for that. So next one is the material jetting, that is for the poly jetting. So these are some of the classification for the 3D printing. So here I will tell something about this diagram onwards. You can understand something. So FDM means I already told this is the extrusion process. So here I will show some examples. So here this material is it has the construction for only that our wire, and next one is the nozzle. So nozzle will come through the extruder. It may be from the 2D plane. Finally, we will get the 3D product. This is for the FDM, very basic things. Second one is these are the things are some advanced. So next one is that this is for the stereolithography. Stereolithography fully based on resin. So resin is cured by the ultraviolet light. So it may be that it may move the z-axis, that is for the thickness direction. So every layer it may be cured. So curing product is the final product. I will tell with a real example. So next one is the selective laser sintering. So next one is selective. This is for the laser sintering. In this arrangement, we have a 2 piston cylinder. The powder will be placed. So due to that ultraviolet ray, so it may be melted. The melting zone is the final product. So next one is the selective laser melting. This is for the, so here this is the sintering. This is the melting. So it may be attain the liquefaction, and it may be melted. It may be give the final product. Okay. So next one is that, and the FDM, the PHIP polyjet, and the binder jet, and the SLA, CLIP. These are the some basic concept. So here the BJP binder jet, we can produce the more color. So because of here in the binder jet, for example, we have to take for the binder jet. So here it may be supplied for the both powder as well as the additive for getting that more color and appearance. So these are the useful for it may be act as casting part. It may be act as a core and molding. Okay, so this is for the usage. And the next one is the laminated object manufacturing. So laminated object manufacturing means it may be the very less cost. We can use the simple paper, ceramic, the simple metal plates, everything we can use as the material. So this is also called as one of the additive manufacturing. So whenever discuss about the laminated object manufacturing, don't confuse about engraving, because of, so here it may be formed as the layer by layer. So we will get that final product. Okay. So next one is that this is for the CLIP, that is for the continuous liquid interface production. So this one, and here the confusing thing is SLA, DLP, and CLIP. These are the this is for the same thing. So CLIP, so instead of the mirror here, they have to change for the projector. Compared here also resin and UV curing, but the compared to the SLA, CLIP is that very fast process. So here I have attached so many videos. So due to time constraint, so I want to wind up. Definitely we will post so many 3D printing regarding 3D printing and contents. Definitely we will post in our RIT MECH center. So definitely contact with us. We will get more knowledge. So now I'm going to share our MECH center video. So definitely it will be understand for so what's going on in FDM as well as digital light processing. So here whatever I discussed. So as far, so I will show through the live video. So here, so this is for that. So everybody know, first one is the 3D software, second one is the slicing software, third one is that our final product. Okay. So yesterday we have manufactured one component for making video. So I have used for that. So Autodesk Inventor software for making so this object. This is for the first step. Just I have made. So second thing, so already told. So after created a 3D object, we want to make, that is for the STL file or OBJ file. So I have created, this is for the STL file. Okay. So this is the second step. So .stl, I mean standard distillation language. So next one is the third step. So we can go for the slicing software. So we are using Cura in our MECH center. So Cura is our slicing software. So you know the function of slicing software. So it may be created for the slicing. So from that we can adjust everything. Here we can adjust the layer height. So and also whenever discuss about FDM, definitely we want to talk about the supporting materials. So FDM in the base is our heating plate. There is no more support. That is very important and also very disadvantage in the FDM. So okay, we will talk. Here we can adjust the fill density. I mean, so what it means. So we can make our object as a hollow. So intermediate object. Whether if 100% means here you can see the density. If we give 100%, we can produce 100% solid object. Whatever we have designed in the 3D CAD modeling. If you want to, whether this is the rabbit prototyping, just so you understand, I hope. Rabbit prototype means show and tell model. We don't need for the 100% build density, just to the showcase only. So we can produce the 50%. Inside we can produce the hollow part. That's like we can changes everything. So second thing, Cura software. So we have to inserted in our machine. So 3D printing machine. This is the final object. So just through memory card only we can access 3D printer machine. So our machine MECH product. So we have inserted. So in the screen we can. This is for the only fusion deposition modeling. In screen we can adjust those things. This is the important. And also before taking this, we want to understand what is meant by calibration. Everybody is the mechanical background. Calibration is everybody known topic. So CNC also we want to calibrate because of whether that workpiece are in center, exact center, or some ovality. So that is that. So here also we want to calibrate our bits are in that correct level. So okay. So like that we want to calibrate. So here our professor calibrate the machine. So here he is preparing and XY. Here also we need XYZ axis. So from we can adjust and we can calibrate the machine very easily. This is the calibration procedure. So we can adjust. So here also one of the knob there. We can in 4 corner we can adjust whether it's okay or not. Just we have ensure. So now this is for the home position. So after calibration, it may becomes like this. So next, we can control our nozzle temperature, bed temperature, everything we can control here because of I already told what you see, what you build. This is the process. If you want to build, you want to ensure your temperature level, material level, and your machine. So here we want to select what type of material. PLA, you should understand PLA is the biodegradable. This results also going on PLA material. You can refer some journals. So here just I have inserted everything. Just we are waiting for temperature rising. Here you can 1 minute you can see in our screen. So I have set everything. And finally this is for part selection. So here this is for the temperature level. We are waiting for the temperature level. Whenever it reaches the 205, here 90, the machine will start automatically. This is the simple process for FDM. So 3D printing technology wise, it may be the very wide, but here the machine and aspects are very, very simple and very easily understand. Everybody can easily understand the machine and learning. So next, I'm going to show what is meant by digital light processing, and that is for the polymerization technique. Okay, so polymerization technique. So here, this is for the in polymerization. Definitely, we want to ensure the safety level because of we are going to use for the resin. If I am going to talk about resin, so it is the wide topic. So we want to talk about rubber, so many things. So we will talk later. So here, this is for the DLP machine, stereolithography. So again, I remember. So what is the difference between FDM and stereolithography? This is for the liquid-based one. So compared to that fusion first model, we can get more accuracy, and also we can overcome one advantage. That is for the advantage that is for we can reduce the supporting level. Okay. So this is for the heating plate. This is for the resin. So resin, it has so many types according to our property. So still research going on for the resin. So various mixing, we can obtain that quality like that's going. So next, this is for that sensitive resin. So here I'm going to, this is for our machine. Here this is the channel vat. Technically they called as the vat. So we have filled the resin here. This is for the heating plate. In the bottom of this unit, UV rays there. So So depends upon the UV curing. So the first in bottom layer is the first layer. First layer will be cured. So finally we will be get the product. So next, so I'm going to talk about RIT MECH Center 3D printing. So this is for the next 3D scanning. So here we have one more thing. This is the final product for the DLP. Okay, very accurate. So just there is no supports. Very complicated parts also we can manufacture. And also 3D printer experts is saying one thing I want to share with you. If your parts are very easy, you don't want to go for the 3D printing because it is utter waste. If you have a complicated part, then only you can go for 3D printing. It may be the profitable one. Otherwise, if you want to produce one nut, you can go and buy in your shop, because of that is the mass production. It may be available. So like that, we want to think about the basic technology. So next, I'm going to talk about the 3D. This is for the curing unit here. So after producing DLP, so it may be the rubber banded stage. So here this is for the UV curing unit. After curing unit, we will be get the final product. Okay. So next one is that I'm going to talk about 3D scan. 3D scan also very wide topic. So here the for example, simple example I will tell, that is for the coordinate measuring machine. So wherever the probe touch, it may be take as the geometry. We can connect the coordinate machine as well as 3D printer. Everything is possible here. So I will show one by one. So here, so I'm going to use for the 3D printer. So our professor using the 3D printing, he showed the images. So from the images, it may be converted into the 3D model. So here this is the 3D software. So it converted the final project. So here it obtained. So this is just the so this is he scanned something. So it converted into 3D object. So from that, you can convert it in the .html file, and we can give the input to the machine. We will be getting the final product. So this is the way we can use 3D printing. So these are the complicated objects we have manufactured in our MECH Center. So here, civil wise and mechanical wise, we have produced, and so plumber block for Sintering laboratory. So EG, we have manufactured some of the components for easy explaining. So everything we can simply use. And also again, you remember, this is the category for rabbit prototyping. This is for the Faber machine. This is for the show and tell model. This is the one of the interesting thing we have produced in the last week. The Bedgy material. So it is a very wonderful thing. This is the we have manufactured hard. So you can see everything very clear, crystal clear manner. So this is the way. So here also you should remember, this is not a one build. This is not a one build product. This is for the split product. Just we have a 3D pen also there. 3D pen maybe after the soldering. We can use 3D printer to join all those splitting material. So here this is the some of the component. So we are using for our additive. This is the Sintering laboratory. So for that we have mat using our FDM machine. So this is for the RIT MECH Center laboratory. So what I'm going to conclude, kindly touch with us. So everything we will upload in the so I mean that is for the CAD Center website. Here I will share something through your WhatsApp. This is for our YouTube channel, as well as this is for our RIT CAD Center website. So we have so many things still. So definitely, if possible, I request the coordinator to conduct 3 more forum for getting giving awareness about 3D printing. So here I need to talk about material. So as well as that, so we have some technical concepts. So okay, I hope so it will be useful for understanding the additive manufacturing concept, and I hope just you can move forward about 3D printing. Thank you. Once again, I thank everyone to give opportunity to share my knowledge. Thank you very much.
I thank Mr. R. Prabhakaran to take this entire webinar on 3D printing related with the basics of 3D printing, types of 3D printing, so how it will be useful in the industry and real world applications, not only for industry, we can use for home appliance also. So it is really useful for us, and also you may ask questions at the end of the session. So next session we are going to start immediately. The topic of IOT. So it will be conducted by Mr. Venkatesh. So you keep your questions in your hand. So we will clarify your doubt at the end of the session. So the next session will be start immediately. Venkatesh. Hello, Amudan. Amudan, Venkatesh.
Sir, can you hear me, sir?
Yes. Venkatesh, have to start immediately.
Okay, sir. Okay, sir.
Amudan is there. Hello, Amudan. Hello, Amudan.
I'm able to hear you, sir.
Yes, sir. You start the session, sir. Please intro about the discuss and you start the session.
Yes, sir. Yes, sir. Yes, sir. Okay. Okay. The next session will be handled by our faculty member, Mr. R. Venkatesh, and Mr. Venkatesh has his specialization in industrial engineering design, and he has completed his engineering design at Tungu Engineering College, Erode, and he has did his UG in mechanical engineering at Nehru Institute of Engineering and Technology, Coimbatore, and he has 4 years of teaching experience, and he has published about 3 international journals, and he has 11 conference publications, and he has also handled Internet of Things for mechanical engineers open elective for our college students, and that is it. And he is coordinating SAE tractor design in our college. That is what about Venkatesh. And now the session is handed over to Venkatesh.
Venkatesh, you can start the session.
Okay, sir. Okay, sir. Thank you, Amudan, for introducing me. So my slide is visible, sir?
Yeah, yes, it's very good, sir. Participants, please mute yourselves.
So good morning, participants. Today I am going to talk about IoT. So IoT. So in Industry 4.0, it comes under the IoT comes under the Industry 4.0. Amudan, you are seeing my slide, Amudan?
Yes, Venkatesh, but your maximization slide is not visible. You maximize your PPT. And now
so now it's visible, sir?
Yes, it is visible. You continue.
Okay, sir. Okay, sir. So Internet of Things. So Internet of Things is it is it is a electronics department. It is a multidisciplinary department. So mechanical students also working in this department, then electrical students also working in this department, then computer science department also, computer science students also can working in this department. So first of all, we got to know about the, so what is mean by Internet of Things. So systems in internally. So because it is suppose in your home, suppose if you are going to office, so suppose if you are going to office in your home, you are forgot to switch off in your light, means so through mobile phone. So through mobile phone you can switch off your light in office itself. So if you are in office, means suppose in your home the refrigerator or TV is working and then bulb is blinking, means so in suppose if you are going to the industry, so you are forgot to this all those things, means in your office itself you can monitor everything and switch off all those electronics items. So this is the Internet of Things, because it is the mobile phone. So in this mobile phone we can connect internally, we can store the remote controller app. So remote control app, so through the internet. So if you are in your in mobile phone, if you are using internet, means so you are already in your mobile phone you are installing a remote controller. So through the internet, so we can, it is through the internet. So the internet, so the connect through the cloud, then in the cloud can be monitored everything. But suppose in your home itself, in your home you are installing sensors, and now recent days Node MC is the best controller in IoT. So nowadays it is implemented. So the Node MCU is the best controller. So in your home you have to install the Node MCU. In that Node MCU you are having in Node MCU it having a sensor. So the sensor senses all those things in your home. Then the signal is passes through this cloud. Then if you are switch on the remote controller means suppose if you are forgot to switch off in your switch off your light or refrigeration or TV means, so it can give you some message to through your phone. So what is the so this is the Internet of Things. Then second one is the industrial IoT. So industrial IoT means in office itself we can control the everything. Suppose if you are in home means, so in your office suppose the 3D printing technology 3D printing is the 3D printing machine is working means, so in the 3D printing machine suppose sir Prabhan sir already handled fusion deposition modeling. So the fusion deposition modeling, the filament is wounded over the box. So in that box it will be having some problems, or the filament is not flowing in through the nozzle means. So in home itself we can see the what is going inside the 3D printing machine. Suppose in filament having any filament is striking into the striking into the wounding box means, so you can stop the machines in home itself. Suppose if you are making one ball bearing in 3D printing means, so it takes around 4 hours to 5 hours. So in 3 to 4 hours. So in 3 to 4 hours we can't sit nearby 3D printing. Okay. So all the times we can't sit nearby the 3D printing. So nearby 3D printing. So we can suppose if time is reached 5 o'clock means, if we are going to home means, suppose still in the process going to complete 3 hours means, in home itself you can monitor everything. So home itself you can monitor everything. So it is the suppose it let us assume, so it is the 3D printing machine means, so in the machines you have to attach to the Node MCU controller. So Node MCU controller we have attached a sensor. The sensor can sense the signal, then send it to the controller. Then controller it has a number connections, hotspot connections. So through the hotspot in home itself we can monitor everything. Suppose if we are in home we are switch on the internet means, so if you are installing the 3D printer monitoring app means, installing in your phone you are installing 3D printing app means, in home itself you can see the what is going inside the 3D printing. If anything any problem happens inside the 3D printing, you can control mobile itself in your by using up in you can control by using up in your mobile in home itself. So in home itself you can control all those things. So that is the industrial IoT. So that is the major difference between the IoT and the industrial IoT. So next I'm going to discuss the connectivity. In IoT there are 3 types of connectivity. So first one is the device to device communication. And then second one is the device to cloud communication. Then third one is the device to gateway model. So first one, device to device communication. So device to device communication. Suppose if you are in your home you are forgot to switch off in your light means, switch off your light means, in home itself you can in your home you are switch off in your light means, in office itself you can switch off in your light through device to device. Suppose it is a device, it is a manufacturer device such as bulb from manufacturer A. So suppose in home itself the bulb is blinking means, so in blinking means through the, so here we are nearby this bulb we can attach the controller. The controller having sensor, some electronics items. Then it is the mobile phone. So it is the mobile phone. So through the mobile phone, if you are switch on the internet means, so everything is perfect or not. So everything you can see. So it is the device. So here in this device, so we can connect So from by using of these two devices, that is a device. So it is a device to device communication. Through the hotspot or through the Wi-Fi, we can connect all those things. It is the device to device communication. Then second one is the device to cloud communication. So it is a cloud communication. So here in the device with the sensor 1 and device with the sensor 2. Suppose if you are working in suppose if you are working in a different agriculture means, so it is a agriculture 1, it is agriculture 2. So in that agriculture you planted some plants. So in plants, so what you are itself, or whatever place you are, so you have to monitor everything through the cloud. Suppose in agriculture, suppose if you are having 1 acre land means, if you are implanting some plants inside the land means, so you can see the what is going inside, whether the temperature, what is the temperature of this locations. So everything you can see here. So through the HTTP and TCP, it is IP, it is the communication protocol. Then here also UDP, COAP, and then IP, it is the communication protocol. So through this communication protocol, we can monitor the what is going inside the agriculture. So agriculture 1, agriculture 2. Suppose in the temperature is reduced in that agriculture 2 area means, so we can monitor that area. Then you have to suppose some plants needs water means, so here some plants it needs water means, so here also you can so the motor is connected, and the motor and the pump is connected to the tank. So from the tank itself you can flow the water inside the plant. So it is the device to cloud communication. So through the cloud we can monitor everything. So another example is if you are using Fusion 360 software. So mechanically we are working Fusion 360 design software. So design software, if you are working in a college, you are using you are making one ball bearing or one flange coupling. If you are doing so in your Fusion 360 is the cloud-based software. So it is cloud-based software. So through the cloud-based software, so once your design is completed or partially completed, it is sent through the cloud. So if you are in home, so home itself you can again, if you are partially completed means remaining partially you have to complete means, you can complete in your home itself. So it can be automatically stored in your cloud. So it is the device to cloud communications. So it is the connectivity. So device connected to the gateway model. It is a device with the sensors 1. It is devices with the sensors 2 means. So through the Bluetooth or smartphone or Wi-Fi. So it is the if you are doing one project. Sorry. So if you are doing one project in your office, so once it is completed, it is sent to the local gateway through the Bluetooth or smartphone or Wi-Fi. So through the Wi-Fi connection, it is sent to the local gateway. Then after local gateway, it will be processed to the application service provider. Suppose if you are in office itself, suppose if you are starting one industry means. If you are starting one industry means 2 employees, employer 1 and employer 2. So employer working in different model means they are sent through Wi-Fi in local gateway. So it is in local gateway you can see so employee 1 is doing perfect or not, and then employee 2 is done perfect or not. So everything you can see here. See in office itself. So it is the device connected to the gateway model. So through the Wi-Fi or through the Bluetooth by using a smartphone, if your employee is done one project means, it's sent through in local gateway. So after local gateway, in gateway itself, you can monitor everything. Suppose local gateway, then local gateway you have to monitor everything. Suppose if anything changes means, you have to inform me here. So that signal, that message is passed through the employees 1 and employees 2. So that is the devices connected to gateway model. one product in a Amazon or a Flipkart, so you can monitor your status status of the product. Suppose if you are tracking in your product means track your product means when the product should be ordered. So when the product should be reaches to us, so everything should be monitored. Suppose it is the express delivery, so it is the express delivery. In your product will be having barcode. So in your barcode we are using, suppose you are going to the Amazon website. So Amazon your website, you are going to in your login. So in your login, if you are already ordered some product, you are ordered some product, you can track your product in mobile itself or a laptop itself or PC itself. Then you have to see. Then Amazon, you are ordered one product means when the product should be reaches to us. So everything will be you have to see, because in your, suppose in the express delivery, suppose in your product order, so the product is available in Bangalore. So in Bangalore, the product should be reaches to Bangalore to Chennai means you have to identify the location of your product. So from GPS, by using a GPS, you have to see the, so where our product is, where it is. So everything you have to see. Then smart parking. So smart parking, it is the most convenient for drivers. Suppose if you are driving in a road, so suppose if you are long time if you are driving, so if you are get tired means, so you have to parking some places means you have to identify by using of mobile phone or car navigation system. You have to identify the parking places. So suppose here in the parking places, so this area is for parking places means, so you have to identify the, so any slot is available for parking your vehicle. So you have to see in hello. So you have to see in mobile itself or car navigation system. So from car navigation system itself, you can see whether the slot is empty. If the slot is empty means you come and drop your vehicle here. Or if the vehicle is full means you have to wait for just 10 minutes or 20 minutes. So it is connected locally, because so it is the location area. So it is the location area. Here CCTV camera is attached. So and then sensor also attached. By the CCTV camera, it passes through the sensor. Then the signal is passes through your communication devices. So from this communication devices, it will GPS connections. So GPS hotspot connections means you have to from management system. So you suppose if you are here means, so you can identify the, so whether the slot is available and the slot is empty or not. So from here itself you have to identify the slot is available or not. Then the signal communication based station. So the signal is sent through the GPS. In GPS itself or car navigation system, you can identify the slot is free or not. Then intrusion detections. So intrusion detection, if you are home in night time, you be inside the home means, so someone some persons coming inside the coming outside of your home means, so it can be automatically produce some sounds by using a PIR sensor and a door sensor, so to detect the intrusion and raise alert. Suppose here IoT devices are IoT devices are attached. So here suppose I am attached a MCU controller. So node MCU controller here attached means, so outside of the door initially in starting itself. So in our family 4 members are there, available means, so initially you have to scan our 4 members face and then iris. So after that if you are going office, then home means it can be automatically detect your face and the iris, then allow you to inside your home. suppose some unwanted persons coming inside your some unwanted person coming inside your home means the sensor does not detect your face on the iris. So at the time we can controller itself, we can attach it one alarm. So in the alarm will be produced some sound. So if night time some unwanted persons are coming outside of our door means so it will be giving some alert to us. So that time we wake up, then so smart by using smart vending machine. So it is done by our students. So this image I taken from Google itself. So my one of the batch students are done the project in this field because it is the rack 1, rack 2, rack 3, rack 4, rack 5, and rack 6. So it is the display board. Then it is the IoT devices. So if you want in that vending machine, suppose if you are having suppose in sixth row it will be having choran, lemon, like this it is available means. So everything should be displayed in that screen. So in that screen by using up capacity touches sensor. So you want to order some product, suppose here snacks is available, or here soda is available, or here cool drinks is available, masa, Mirinda, that cooling is available means. So you can click over here. So it is like one type of mobile phone. So which product you have to want means you have to click. If suppose if you want a Mirinda means you have to click a Mirinda here. So then here it shows Mirinda rate. Suppose 2 liters 100 rupees means 2 liters 100 means 100 rupees means through the ATM you have to swipe your card here itself. So then after that, if you are paying money means in bottom itself you can collect your product. So which product you have ordered means you can collect your product. Then futuristic word. So then so next generation is IoT. So in industry 4.0 already came. So they are Samsung and Google's are here. Previous itself they are aware of it. Now the Samsung purchased one smart cities around $320 million. They have purchased smart cities. Then Google also purchased Nest company. It is fully automated. So now the technology is now industry 4.0 technologies also came. So the Samsung and Google's initially aware of it. So the technology, so 3 years back in the aware of it. So next 3 years in the IoT technologies will come. So they are initially in the 3 years back they are aware of it, and then they are purchased smart cities and Nest company. Next I want to tell about some basics of electricity. So basics of electricity, there are 3 things: voltage, current, and resistance. So voltage means suppose the water tank is in first floor means the pressure will be pressure will be low. Suppose if the water tank is in third floor means the pressure of the water will be high. So due to the suppose it is the voltage, so it is the height. Suppose if if your water tank is located in your first floor means at the time the water will come slowly. If it is third floor means the water pressure will be high. That time water pressure will be high. So that time the current will be high. So the pressure is here current. So the pressure of the water is here current. Then here in these 2 water tanks, so these 2 water tanks, here the diameter of the outlet pipe is high, and here the diameter of the outlet pipe is less. So same capacity. Suppose here it's here diameter is high, so the water is flowing. Water. Hello, it's audible, sir?
Yes, Venkatesh, you continue.
Okay, sir. So if the diameter of the pipe is very large, it means the water will be easily come out very fastly. So if the diameter is very small, means the water will come very slowly. So pressure will be high, but the water will be. So here in the 3 seconds water can be dry out, means here it takes around 6 minutes or 7 minutes it takes, because here resistance is there. Then third thing is the resistance, less resistance, more resistance. So if less resistance means the current flowing very fastly. If more resistance means current flowing very slowly. So voltage means it is the potential difference between the 2 points. So it is the voltage is nothing but a potential difference between these 2 points. Suppose if the water tank is the water tank capacity means 1 liter means, so 1 liter after 2 minutes if I am available means, if I open this tap means open the tap in 2 minutes means it is some water will be going, water will be reduced. So initial position and the final position. So it is the potential difference. It is the potential difference between these 2 points. So current is the amount of charge flow. So if the diameter of the pipe is diameter of the pipe is large, means the water can be easily dry out. If the diameter is very small, means it can be dry slowly. Then resistance. So resistance already, if it is less resistance, then the current will be passed high. If the more resistance, means the current will be passes very less. Then Ohm's law. So Ohm's law. So it is the backbone of electrical and electronic department. It is in this law. It is directly proportional to the voltage and the current. So V is the voltage. So in the unit of the voltage is volt. Then I is the current. So current unit ampere. Then R is the resistance. So resistance unit ohm. So breadboard. So suppose why we are using breadboard in electrical and electronic department. Suppose if you are having variety of connections, means all the connections we can't solve all those things. So for this purpose we can use this breadboard. So because yeah, suppose if you are making one bridge circuit, means so on that bridge, if you are making one bridge circuit, means that bridge circuit you are using variety of wires, means that variety of wires can't be solved. So suppose once you solved, means again and again you can't solve all those things. So for this purpose we can use breadboard. So now I am going to small demo by using Tinkercad platform. So in Google you have to type tinkercad.com. In Google tinkercad.com, so you have to Tinkercad create 3D design. So you have to click over here. So my voice is audible, sir?
Your voice is audible, but your screen is not visible. You do one thing. So in your presentation mode, you change it as the entire screen. Your entire screen.
Wait, sir.
In presenting mode, you change as your entire screen. Venkatesh, hello.
Yes, it is visible, sir. So, Brito sir, can you audible?
Venkatesh, you are audible. You are audible.
Venkatesh, so you
sir.
change your presentation mode as your entire screen. Then only you can we can see your website. So you are typing something through browser. Is it correct?
Yes sir, yes sir.
If you want to show that, you just change the presentation mode as your entire screen.
Yes sir. It's visible, sir. Sir, it's visible.
Wait, Venkatesh. Now it is visible. You continue.
Okay, sir. Okay, sir. So in Google itself, you can type www.tinkergut.com. So tinkergut.com. So once you have to type it, so you have to give enter. So give enter. Suppose if you are newly joined means you can give join now. So before going to join now, so you have to ensure your antivirus. Suppose in your laptop you are using Android, Avast or Kaspersky, some types of antivirus. If you are using means you have to kindly disable this. Then second thing is so here this lock button. So here location, so camera, motion sensor, images. So all those things you can give allow only. Suppose if you are giving ask default or block means it will not be working. So all those things give allow only. Then third step means still you are having. Suppose I am going to give join now. So join now, create a personal account. Suppose if your school means you can have a less than 18 years old means you and that less than 18 years old students cannot be working in this platform. So that time they can go to the students account like that. So best way is you can go to the here only. So create a personal account. So create a personal account. You have to sign up with the email. So you can sign up with the email. So here our state is asking. So you can give India. Then you have to give your date of birth. So date of birth, suppose you can. So 1992 means, so you can give a next. So it's loading now. So the network is very slow. Then here asking email and password. So you can give your email ID. Then you have to give your password. So in starting itself, you can it is a create account. So you can give your email ID. Then you can give a password. Then you have to click I agree to the Tinkercad terms of service. So you have to click over here. Then after that you have to create account. Suppose I am giving R at ritrjbm.ac.in. So ME. Then agree. So create one account. So already I am having account. Suppose if you are having one account means it does not work. So suppose it is in this mail ID is new means you can give. Suppose if your Probot .com Tinkercad.com, click enter. So click enter. So you have to, if you are having already account means you have to go to the sign in now. So sign in with the email username. So you can give your mail ID Venkatesh or at RIT or em.ac.in. So the Tinkercad dashboard is now opened. So it is the Tinkercad home. It is the Tinkercad home. Then here in left side 3D design, circuits, code blocks. So we are making circuits. So you have to click circuit over here, then create new circuit. So it is the library. So in this library there are electronics components are available. It is the components library. So first of all I want to glow on LED. So I'm going to pick and drop on LED here. Then after that in LED I want to give you one voltage supply. So you directly pick and drop. So once I deleted this, once again you have to pick 9-volt battery, then drop it here. So it is the positive terminal. So it is the negative terminal. So the positive terminal should be connected to the anode. The negative terminal should be connected to the cathode. So once you have to click that point. So once again I repeat this. So I'm deleting all those things. So once you have to pick and drop on LED here, then if you want to change the LED color means you can change the color. So once you have to click over the LED, so here it shows color, red color, green color, yellow color, orange color. So once you have to click the, if I want yellow color means click over the yellow color. Then after that I want to give you one voltage. So here 9-volt battery is available. So pick and drop on 9-volt battery. Then I give you some connections. So it is the positive. So positive terminal should be connected to the anode terminal. Then negative is connected to the cathode terminal. So here the 9-volt battery. So 9-volt supply is going through the LED. So now I give you a start simulation. So now my LED gets banned. So why? What reason, sir? Anyone tell? So anyone tell?
Volt, sir.
What, sir?
9 volts, sir.
Yes, voltage is high. So here there is a 9-volt battery. So in 9-volt battery, if you are using resistance means no problem. The LED is glowing. So now I delete this connections. Now I am going to install the one resistance. So in resistance you have to pick and drop it here. So you have to change the resistance orientations means you have to once click the resistor, then you have to change the directions of your resistor. So it is the bipolar connections. So you can connect anywhere. So it is not a positive, it is not a negative. There is no options here. So it is the bipolar direction. So you can connect anywhere. So then anode side to resistor I am connecting. Then terminal 2 to positive side I am connecting 9-volt battery. So at the time you have to give the resistance value. Suppose I am connecting here 9-volt battery is available. So here LED is. So here I am attaching one resistance. So initially we does not attach a resistor. So only high voltage passes through this LED. So it is easily ban out. So I am now we are attached one resistance here. We are connected one resistance here. So resistance can be resist the voltage. So in we need a resistance value. So by using Ohm's law, suppose in Ohm's law, so V is equal to IR. So voltage equal to current into resistance. So we need a resistance value means so R is equal to V by I. Sir, whether you are seeing my slides, sir? Ditto, sir?
Yes, Venkatesh, you continue.
Okay, sir. Okay, sir. So R is equal to V by I. Here our voltage value is 9 voltage. Suppose if you are buying one LED in the market means in LED itself it can be mentioned in the record current for this LED is 20 milliampere. 20 milliampere. Then record voltage for this LED is 2 voltage. So that things will be intimated here. So now R is equal to V by I. So V is equal to, suppose we are supplying 9 voltage here. So 9 voltage battery I am attached here. So 9 voltage supply voltage is 9 minus the record voltage for this LED is 2 volt. So 9 minus 2 divided by the record current for this LED. So if you are purchasing more than 10 LED means the box itself it's mentioned in the record voltage for this LED, then record current for this LED, everything it will be mentioned in the box itself. Now the current is 20 milliampere. So 20 milliampere means 20 into 10 to the power of minus 3 ampere. So equal to 7 into 10 to the power of 3 divided by 20. So in calculator, so 7,000 divided by 20. So 350. So our answer is ohm. So here the resistance value is 350 ohm. So you can directly give the resistance value. So 350. So if you want to change the unit of this resistance, you can change. It is a micro. So you can give 350 ohm. So 350 ohm means 350 ohm. Now you have to give the start simulation. Now my LED is blinking. Instead of 350, you are giving instead of 350, you are giving 150 means the LED is glowing. So with the warning. glowing, but with warning. So LED is glowing with warning. So if the symbol is source means the LED is not comes long time. It will not work a long time. So only, so you have to, once you have to calculate by using of Ohm's law. So by using of Ohm's law, V is equal to IR, so R is equal to V by I. So by using of Ohm's law, you have to calculate the resistance value. Then you have to put it here 350. So we have found the 350 value, 350 ohm. So now LED is glowing without warning. Okay. So if you want to, so this is the one project. So if you want to rename this project means, so you have to double click on over here. So then I am going to give project 1 P1. So P1 means will be come. Okay. So again you go to the Tinkercad home. You can see your project. So it is the open source platform. So in Google itself, you can type tinkercad.com. Tinkercad.com given means, so in software side, you can easily try out. After that, suppose if you are facing some problems, means suppose here already shows LED with warning means, so you can software side, you can once you have to check it, then after that in real time you have to connect the battery, LED and resistance, then you have to give the LED resistance value. So in real time we can't do all those things. So it is a software side only, it can do all those things. So again I'm going to draw another project. So go to the circuit. So circuit, then create new circuits. So I'm going to take a 9-volt battery here. Then I am going to so DC motor. So then photoresistors. So next I am going to do a one LDR project. So the LDR means it is a light dependent resistors. So light dependent resistor, it is the photoresistor, it is the 9-volt battery, it is a DC motor. So everything you have to pick and drop it in your library. So every electronics instrument is available in your library. So once you have to pick and drop it over here. So now I'm going to give the connections. So then positive. So then positive side I'm going to connect in positive terminal 2. So positive in the motor, it is a forward motions. So the positive terminal, it is connected to the positive terminal of the DC motor. Then negative side, it should be connected to the terminal 1. Then terminal 2 to terminal 1, you have to connect all those things. Suppose if you want to change this wire connections, mean you can change. Suppose you have to double click over here. Here you can change your color, orange color. You need orange color means orange color, or red color means red color, or you need a black color means you can give a black color. So you have to double click over here, then you have to see the variety of colors. Okay. Suppose if the place is very congested means congestion means you can do a zoom to fit, so you can see clearly. So once you have to give the zoom to fit means, so every circuit you can see visible. So now I'm going to give you start simulations. So the power supply and the voltage is given to this DC motor. So if the armature is high means, if the armature is high means the resistance will be high. If the armature is very less means the resistance also very less. Suppose if you are shrinking one wire means, so the flow of electrons will be disturbed. So that time the current will not pass smoothly on this pathway. So if the armature of this photoresistor means high means the resistance also high. So if the armature is very less means the resistance also very less. So now I'm connecting all those things. So now I'm giving start simulation. So from itself, so click over photoresistor. So you can increase the brightness of your photoresistor means you can see the RPM of this motor. So now I'm increase the brightness of this photoresistor. So now the 1000 full brightness given. So here the maximum RPM is 1973 RPM. So in real time in hardware you can't see all those things. So you can't see the RPM of this motor. Without any device you can't see the RPM of this motor. By using of tachometers only you can see the RPM of this motor. If you are increasing the participant, kindly mute your mic. Okay. So it is a LDR project. So double click over here, you can give LDR. Already time reached 12:05. So within 5 minutes I can conclude my session. So LDR project means you can give LDR. You can rename it. Okay. So once the circuit once stop simulation, then you go to home page. Tinkercad home. So I can conclude my session. So we can try over on another project. So in that circuits. So go to the circuits, then I think it's loading. My bandwidth is very low. You can operate anywhere. So in home itself, suppose if you are doing in college itself means you can do in your home itself. So no problem. So create a new circuits. I'm going to take on Arduino. So it is the Arduino Uno board. So it is a USB. It is the jack. It is the digital pin. So it is the digital pin. It is the boost button. So here 0 to 30 pins are available. Here the mentioned -11, -10, -9. So it is a minus me. It is the PWM. So PWM means pulse width modulations. Suppose if I am connecting LED over, if I am connecting LED over here means I am going to give you a constant. I'm going to give you a constant voltage means you can give select a pin number 13, then pin number 12, then pin number 8. Suppose if you are varying voltage of connect to the pin number 11, then pin number 10, then pin number 6, pin number 5. So they clearly mentioned digital PWM. So it is the digital pin. So it is the microcontroller. So if you are connecting with the analog means you can use this A0 to A5. So it is the power. So if you are connecting your mobile phone means you can connect it here. Then you have to 5-volt supply going to passes through in breadboard and Arduino. So the main advantage of this Arduino is all the circuits are inbuilt. So in bread, if you are once suppose if you are using breadboard means you are connecting so many wires here. So many wires here means so you can't bring all those places. So you can't you can't bring all those places. So it is a major advantages over breadboard. So I'm going to, by using of Arduino board, I'm going to blink on LED. So once click over here, I want to change the LED color. You want to change the LED color means you can change it, or otherwise you can keep it red color. Okay. Yes, it is the cathode, it is the negative terminal, it is the positive, anode is the positive terminal. So cathode terminal I connected through the ground connections. So cathode terminal I am connected to the ground connections. In positive terminal I am connected to the pin number 12 or 13. Suppose if you are giving constant power supply, constant voltage means, so you can give plus value 13, 12, 13, 12 or 8 or 7 or 2. So that pin you have to connect. So I'm going to connect pin number 13. So pin number 13, I'm going to connect. So you next you have to go to the code. So go to the code. It is a block. So in output value, it's a block. Then blocks plus text, then text. So you have to click the blocks plus text here. So blocks plus text means suppose you already made it. So you can put it in the dustbin. So output is there are here so many blocks are available. So many blocks are available. So suppose if your LEDs blink 1 second means 1 second it will be glowing, then another 1 second it will be glow up means you can give the conditions. Suppose I'm going to take this block. So it is a set pin. So I'm going to take a second block. So second block I'm to set a pin. So set a pin. I'm going to give a pin number 12. So pin number 12 means so. Nice. Participants kindly mute your mic. So it is a negative. It is connected to the negative. It is connected.
Sir, Venkatesh sir, please unmute yourself, sir. Venkatesh sir, can you hear me? Venkatesh sir. Sir, Venkatesh sir, unmute yourself. You are muted.
Okay, sir. Now it's okay, sir.
Yes, okay. Just you can press 1 second.
Okay, sir. Okay, sir.
Now okay.
Okay, again I want to. So it is I'm going to, so by using of Arduino Uno board, I want to glow one LED here. So okay. So I'm choosing Arduino board, then LED in negative cathode is connected to the ground, then positive is connected to the positive, that is anode is connected to the pin number 12. So in code, I'm going to take this block. So because my LED is because 1 second LED is blinking, then next 1 second my LED is up, next 1 second my LED is blinking means you have to give the conditions. So by go to the code, then click over the blocks plus text, then click over the blocks plus text. So here output, so the output here n number of blocks is available. So I'm going to select a second block. Suppose if you already taken means you have to put it in the dustbin or delete it. So here I am going to set a pin number. So I'm going to, here I am going to connect to the pin number 12. Suppose if you are connected in a pin number 7 means here you have to give the pin number 7. Then control, then go to the control, then go to the first block. So you have to directly just pick and drop it here. So here how many seconds it will be glowing, then how many seconds it will be glow up. So that seconds you have to mention here. Suppose 1 seconds or 3 seconds or 4 seconds, 5 seconds means you have to give the seconds. So if I am going to give you 5 seconds means, so once 5 seconds the LED is blinking, then after 5 seconds the LED glow up. So blink after 5 seconds the LED glowing, and then after 5 seconds the LED glow up. So you have to give your conditions here. So once you have to completed, you have to give start simulation. So you have to give start simulation. So my LED is glowing. So glowing with warning. So here my LED, suppose if you are connected in the ears means, so here the 5 volt is applied to the all the circuits. So it is the microcontroller, through the microcontroller and the 5 volt is applied to ears. So here the resistance is not available. So resistance we are not connected. So only it gives you a warning. The current through this here you can see the current through this LED is 53.5 mega ampere. The recommended maximum is 20.0 mega ampere. So the record current for this LED is 20 milliampere, but we are having now we are having 53.5 mega ampere. So only it's warning. So in real time we can't see all those things. So if it is my LED is glowing but with the warning, so on the life of the LED becomes very less. It shows some warning means my LED gets damaged easily. So now I stop simulation. Then I delete this connections. Then I have to connect the one resistor over here. So you want to change the directions of this resistance mean you have to directly click the resistor, then change the directions of the LED. Then you have to connect the LED positive to resistor terminal 1. Then resistor terminal 2 you can connect anywhere 7 or 13 or 12. So if you are giving constant voltage means you can give positive points. So that is 13 or 12 or 7. Suppose if I am going to connect a 7 means that in code you have to give a control. So set a pin number 7 once you have to given here. So after that in output, so in you have to make a one duplicate blocks. Suppose now LED is blinking only, now LED is glowing only. So I need to stop or off the LED means again you have to give the duplicate. So once you have to click this blue color block, then click right side, you can have your own options duplicate. So you have to click over here duplicate, then drop it here. So same pin. So here I am connected 7, pin number 7 and pin number 7. So it is a too high means the LED is glowing. So it is you are giving low means the LED becomes off. So everything you have to give. So we are giving 5 seconds. So 5 seconds the LED is glowing. Then after 5 seconds the LED is glow up. So you are giving some conditions mean automatically the program is generated. To give the start simulation. Start. So 5 seconds LED is glowing. Then after 5 seconds the LED glow up. Then after 5 seconds the LED glowing. Okay. So you can see this program. So you can write manually anything. So you can see this program, then you have to put it over in Arduino software. So Arduino software, you paste it over there. You can working with the Arduino board. Suppose if I am deleting this block, means that one line delay 500. Sorry, delay 5,000. So it is here showing milliseconds. So 5,000 milliseconds. So we are giving seconds. So I deleted this, means you have to just click over here, then put it in the dustbin or deleter. So deleter means that one line will be gone. So here digital. So 7th number we are connecting in the 7. So it is low. High means the LED is blinking. It is low means the LED is blink up. So put it over here, means you can remain, you are having 2 more blocks. So you can see delay. So we are giving 5 seconds. So here mentioned in 500 milliseconds. So we are digital right. So 7 high. So it is the program. Suppose if I am deleted this. So remaining digital right 7 high. So these 2 things are only available. So you can visualize. So you can practice everything. So here a number of blocks is available. So you can click over there. So how the program is changes. So you can visualize in your program. So it is the open source software. So it is very useful for making. You can make to build a one circuits. So here itself I can wind up my session. So participants, any doubt? So ask in the chat box. I will clarify your doubts. Brito, sir.
Amudan, conclude the session.
Okay. I thank Venkatesh for giving a nice presentation about Internet of Things, and he has given information about Tinkercad online platform where you can test your electronic components virtually. So that is the new information from this Internet of Things session. Thank you, Venkatesh sir. Participants, if you have a doubt regarding 3D printing or Internet of Things of that virtual platform, you can ask your doubts through orally, or you can type your doubts in the chat and they can reply you.
Okay, sir. Once again, thank you, Amudan sir, Brito sir, Prabhan sir, for giving opportunity to present in the public forum, sir. Thank you, sir.
Participants, if you have any doubt, you can ask them. Sir, Prabharan sir. Hello, Prabharan. There is a doubt for 3D printing. Can you see it? For IOT, can we control a machine automatically without human? If yes, how? What is cloud? Please explain again briefly. Device,
Yes,
local
sir.
gateway, and things. Artificial intelligence. He has given a lot of questions. Okay.
So, okay, sir. So one of the participant Ambrose are asking questions. So I can see. Can you please briefly explain about secondary manufacturing process? Already we have discussed in the rapid prototype manufacturing. It classified into 2 things, sir. First one is the rapid, that is the direct tooling. Second one is the direct manufacturing. From the direct manufacturing means we can produce the product in the end. So we can produce the end of the product. That is for the direct manufacturing. For example, layman word, I already explained. If die means that is for the, we can produce the die. It is not a final product. That is for the direct tooling. So indirect way means, indirect manufacturing means after producing additive manufacturing component, we need to improve some hardness, yield stress. So for that purpose, we are doing something for the heat treatment process. So it may be considered the category for secondary manufacturing or indirect manufacturing that way. And also somebody is asking what is resin, why resin? So I want to explain more thing about this question. I mean that 3D printer we can classify in some of the way, the powder metallurgy, so liquid resin based one, or extrusion based one, or solid based one, metal 3D printing. This is the one category that is for the photopolymerization technique, that is for the resin. So here the resin is act as our material. So resin selection is one of that very vast area. So it depends upon the stability resin, so vast resin, so flexible resins, resin types are so more. So depends upon our application, we can select the resin. So here the DLP process, and also our ball jet machining also, and the next one is the CALP process. With the three process, we are using resin as the one of the material. So next,
Okay, the
is
next
there any other
question
questions?
yeah, he has asked another question. Can we control a machine automatically without human? If yes, how? Okay, another thing is he asked what is the difference between Internet of Things and artificial intelligence, and what is cloud communication. And okay, the cloud is nothing but you are having a separate server for in every college or every place. There will be a server. Only in that server, softwares will be installed, and every computers will be getting the software from that particular server. So if you are able to access a server from internet, that particular thing is called cloud. So if you are having a Google Drive is an example for server. You are storing your pictures, or you are storing a large amount of data in internet. That particular platform used for storing is called as cloud. So the difference between IoT and artificial intelligence. In Internet of Things, what you will be doing is you will be connecting all the machines, all the devices with the help of internet. So you can access them at a remote location. If your machine is accessed to if it is connected through internet, you can automatically work on it through internet, through your mobile phone or a basic application. Artificial intelligence is an idea where you can make your machines to work independently. It will be able to, it can perform some decision making operation. Your machines will be working based on that. The backbone of artificial intelligence is coding. Coding or the algorithms or the mathematical model what you are developing is the backbone of artificial intelligence. But in case of Internet of Things, how you are interfacing your hardware with hardware to one another, and how you are transferring data is the backbone of Internet of Things. Clear? I hope you are clear with it. Okay. Okay. Participants, sir, Brito sir, are you here, sir?
Yes, sir.
Sir, now I will share the feedback link, sir. Let the participants complete it, sir.
Okay, you will give 15 to 20 minutes for.
No, sir. Sir, as planned, what we have done is we have planned for 10 minutes, sir. Within 10 minutes, participants will be able to complete the feedback link, sir.
Okay, we post it, sir. Post it.
Posted it, and participants, please make use of it.
Okay, okay.
So if you have any doubt regarding technicals, you can contact RIT MECH Center mail, and also you can contact WhatsApp. And also you can view through a recorded video also available in YouTube link. You can subscribe and view and enjoy.
Prabharan, there is another doubt here. Please go through the chat.
Yeah, sure. Sir, here, so 3D printing, what is the range of material thickness to be done, like minimum and maximum? So everything depends upon the machining and the bed size, sir. So whenever you buy, so the